Today I'd like to talk about sources of bias. So please turn in your study guides to the notes on sources of bias. Let's first begin by talking about a random digit table. Now, in a random digit table, each entry is equally likely to be any one of the 10 digits 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. Now, the digits are independent of one another. Here's an example from a statistics textbook of a random digit table. Here's an excerpt of this table in the first 3 rows. Now, numbers can be read horizontally in either direction. We could also read numbers vertically in either direction. And numbers can be read diagonally as well. So there's several ways that we could use numbers from a random digit table. We can read them across horizontally, we can read them vertically up and down, or we could read them diagonally. Now let's take a look at an example using a random digit table. Suppose your population consisted of these 20 people. So we've got 20 individuals, we have our sampling frame, and each of these individuals is numbered from 1 to 20. Let's use the random digits to select a sample of 5 from these people. So we're going to use this excerpt from the random digit table here, and we're going to select 5 individuals from this population of 20. Now obviously this is a very small population. We could do a complete census on this if we needed to do it, but just to give you an example of how we could select from a population using a random digit table, let's just assume our population is very small and that our sample size we want to select is just 5 individuals. Now let's begin by reading across the rows. Since there's 20 individuals in our population, we're going to need to use double-digit random numbers, and we're going to ignore any numbers greater than 20. So let's begin with row 1 and read across. So the first number we encounter is a 45. Now, since there's not 45 individuals in our sampling frame, we're going to ignore this result. So we simply cross it out. Continue reading across. Our next double-digit random number is 18. Since 18 is a number that's actually part of our sampling frame, we're going to choose that individual, which is Tracy. The next double-digit random number is 05. That's Edward. The next double-digit random number is 13. That's Matthew, so we select Matthew as well. The next double-digit number we encounter is a 71. We're going to ignore that since that's well above 20. Going down to the second row now, our first double-digit random number is 01, so we select Aiden. 55 we will ignore. 80 we'll ignore as well. And finally, number 15 is Opus, so we select Opus. Stop when 5 people are selected. So my final example, based on this random digit table, would consist of Aiden, Edward, Matthew, Opus, and Tracy. Now we could get varying results based on this random digit table depending on how we decide to use the random digits. We read the random digits horizontally going from left to right. We could have read it up and down or at diagonals and got very different results. Now let's talk about bias. Bias is basically the favoring of certain outcomes over others. Bias results in error. Bias is anything that causes the data to be wrong. It could be attributed to the researchers, the respondent, or even to the sampling method itself. So bias is definitely one thing that we want to avoid when we're trying to create samples that are representative of populations. When choosing a sampling method, it needs to be a sampling method, as we described earlier in our lessons, one that incorporates the element of randomness and where every individual typically has an equally likely chance of being selected, such as the simple random sample and some of the other sampling methods that we talked about. If we don't incorporate this element of randomness, then choosing samples based upon what we think might be good will perhaps lead in bias, and there's nothing we can do once our data is biased. So if we try to base results on a biased sample, then we're going to end up with bad results and ones that really can't be reflected